All right, so today we're going to talk about two different functions. We finished quadratics the other day. We're going to talk about square root functions and absolute value functions. We'll do a little bit with lines, but really with lines, I want you just to continue to do what you already know how to do and graph them using y equals mx plus b. So this is day 2. There'll be a third day of this, and then we'll move on to a review and a test over this material. So we're going to start with square root functions. Now I'm going to fill it out here on the note page that you received. You can then take it and transcribe it onto your parent function chart that you have that we got last time we were in class. So our parent function is y equals, remember f of x is the same as y, equals the square root of x. And so we can't take the square root of a negative number. Then we end up with I, which is a non-real number. So we'll start with 0, and the square root of 0 is 0. Well, the next number we can take a square root of is 1. The square root of 1 is 1. Because remember, f of x equals the square root of x. Then we have 4, and the square root of 4 is 2. Now, I didn't pick an x of 2 or 3 because I can't take a nice even square root of those. And then we can have 9, and the square root of 9 is 3. So then we're going to go plot those points over on our graph. So we move over to the graph. And you see that we have a point at 0, 0, and at 1, 1, and at 1, 2, 3, 4, and up 2, and over 9, and up 1, 2, 3. And then you're going to connect those, and that's the basic shape of the parent square root function. Okay, now we did a lot with calculators last time. We're not going to use those again today, but we take that whole graph and shift it left, right, up, or down, depending on what the equation tells us to do. Now the domain, if you notice, the lowest value of x is a 0, so the domain goes from 0 to infinity, and the range is also from 0 to infinity. The parent function goes up and to the right. Now, if we remember what we did the other day, I'm going to give you a minute to look at this and to write down what you need to write down, because I'm going to go off of it. Okay, and I'm going to go off of it, and I'm going to delete that and move this up so you can see. Now we're going to do some of these transformations. So if you remember the other day, when we had the negative in front, it made it reflect over the x. Well, if it reflects over the x, then instead of starting at the origin and going up, it's going to start at the origin and go down and to the right. So that's what our graph is going to look like. But the basic moves, if you think about the moves from the origin, start at the vertex, which is 0, 0. And so instead of over and up, you go over and down 1. You're going to go over 4, 1, 2, 3, 4, and down 2. And over 9 and down 1, 2, 3. And then that's your parent function going to the right. Okay. Now I'm going to go through these pretty quickly. You can stop between them and think and give yourself time to draw. But just for timing of the recording, I'm going to go through them fairly quickly. Plus, this is grouped in with the x. See, it's under the square root symbol with the x. So this is a left or right shift. X plus is left, just like it was with a quadratic. So instead of starting at the origin, I'm going to start 1, 2, 3, 4, 5 units to the left. So my new origin is now at -5. But from that spot, you're going to go over 1, up 1, over 4, 1, 2, 3, 4, and up 2, and over 5, 6, 7, 8, 9, and up 3. And so your parent function, all of that plus 5 under the square root symbol made the whole graph shift left 5 units. Now this next one, I'm going to have to move this up, so I'm going to have to erase these and go up to the x minus 1, okay? That's going to move it right 1 unit. So my new vertex is here at 1, 0, because instead of at the origin, it's moved right. Go over 1, up 1, over 4, 1, 2, 3, 4, and up 2, and over 9 and up 3. So the whole thing shifts right 1 unit. When you have the minus 8 not grouped in with the x, but outside the x, in this case, the grouping symbol is the square root symbol, it makes the whole graph shift down. So you're going to go down from the origin 8 spaces, 1, 2, 3, 4, 5, 6, 7, 8. Put a dot. Over 1, up 1, over 2, over 4, up 2, and over 9, and up 3. And you put those points in there, and there's your graph. And the whole graph shifted down 8 units. Each point is 8 units lower than it was on the parent function. So again, stop this if I'm going too fast and you need time to grit this on your graph, and restart it when you need to ready to go on. Okay, so we've got a couple more transformations to graph. This one is a vertical shift up 3 units. So instead of at the origin, now my new vertex is at up 3. And you're going to go over 1, up 1, over 1, 2, 3, 4, and up 2, and over 9 and up 3. And there's that graph. When you have the vertical upshift 3 units. The number in front, this 2 in front here, is a stretch by a factor of 2. So there's no left, right, up, or down, so I start at the origin. But instead of going up 1, I'm going to go over 1 and up 2. You multiply your y values times 2. So I'm going to write over here y values times 2, okay? So normally I'm going to go over 4, 1, 2, 3, 4, and up 2. But 2 times 2 is 4, so I'm going to go up 1, 2, 3, 4. And when I go over 9, I normally go up 3, but 3 times 2 is 6, so I end up here at 6 for 9. So you can see, just like the quadratic caused a stretch, a vertical stretch, this also stretches it up. You don't get the sense of the skinnier and wider like you do with a quadratic, but it does stretch it up. If it was less between 0 and 1, it would be all shrunk down or compressed closer to the x-axis. Okay? So that's kind of just the graphs of what we're going to deal with square root functions. And so the effect on the graph, again, we did this with quadratics. The negative in front is a reflection over the x-axis, so it reflects over the x-axis. Grouped in, and so remember, both of these, when you have your left-right shift, they're grouped with the x. And this grouping symbol is a square root symbol. Okay, so the reflection is this negative in front. Other than being grouped in with the x, we have to look at the sign. And so that means the plus means it's going to move left h units. And the minus means it's going to go right h units. Okay. Again, this is out here by itself. It's not, you see that the top of that square root symbol doesn't carry on over. And so this is outside the square root symbol. That makes it go up K units. And the other one is down K units. Okay, that minus. This A in front is going to be a stretch or a compression. It's a stretch when A is bigger than 1. That makes it move up higher. And it's a compression or a shrink also you can put shrink when A is between 0 and 1. It's a small fraction. So let's look at what happens in this next graph. But I'm going to have to get this off, so don't move on till you have this written down because I'm about to erase it all on mine. So we're going to move here to this one. I'm not going to make you fill in the graph of the parent function. Let's just look. The negative means we have a reflection. The minus 3 means you go right 3 units. And the plus 4 means you go up 4. And there is no stretch. There's no number in front of the square root symbol. So our starting point normally is at the origin. But we're not going to start there. We have to find our new vertex. So we're going to go right 3 spaces, 1, 2, 3. And we're going to go up 4 spaces, 1, 2, 3, 4. And there's our new vertex. Right 3 and up 4. Then from there, it's a reflection. So instead of going up, it's going to turn down. Like that. Okay, so we're going to go over 1 and down 1, over 4, 1, 2, 3, 4, and down 2. And I can't go over 9, I'll be off the graph. So I can just draw this square root graph like that. Okay. The domain starts at 3. Remember, a domain is your x values, so the point here on the graph that we started was 3, 4. So domain starts at 3, and it goes to infinity, and it does include the 3, so that's a square bracket. The range starts at 4, but it goes down, and we always put the lowest number in the range first. Range, again, is y values. So we're going to put our negative infinity first since it's going down, and it's going to go up to 4. So when it opens down, just like with a quadratic, your range is going to start with negative infinity. Okay, let's move up to the next graph, the next example. Okay, this one does have a stretch. Okay, so we've got stretch by 2. It doesn't have a reflection. So you've got a stretch by 2. You've got a right 1 and a down 3. Okay. So first start at the origin, that's your starting place, and you locate your new vertex. You're going to go right 1 and down 3, and there's your new vertex. From the origin, you moved right 1 and down 3. Now you're going to go over 1, but since there's a stretch, you go up 2. So start at the origin, start at your new vertex and go right 1 and up 2. Then you go back to your new vertex, and you're going to count 1, 2, 3, 4, but instead of going up 2, you're going to go up 1, 2, 3, 4. And so there's another dot. And I'm going to go right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1, 2, 3, 4, 5, 6 right there. Normally we go up 3, but 3 times 2 is 6. And so there's the new graph. If that was a 3 in front, you would multiply all your y's by 3. Your domain starts, this point here is at 1, -3. Oh, I made a mistake. So I gotta erase all this. I wish you could have been there to tell me I made a mistake. Where's my mistake? Hopefully you recognized it before I did all this. This should have been left. Left 1. Okay. So it's left 1. So we're going to go left 1 and down 3. So there's my new vertex. Over 1 and up 2. Over 4, 1, 2, 3, 4, and up 4. And over 9. And up 1, 2, 3, 4, 5, 6. So my domain is from -1 to infinity. And my range is from -3 to infinity. And this is the point right here. My vertex point is -1, -3. Okay? So, let's move on. Now we're going to write some equations. So writing the equations, again, this tells you what to start with. Eventually there's going to be some of these things that are mixed up on here. They're going to be not just all the same one that we're working on for our homework. They're going to be mixed up. But this is use square root of x. Okay, so you want right 2 and up 4. So y equals square root. Under the radical is your left and right, so that's going to be x minus 2, and outside is plus 4. Be sure that up or down shift doesn't float up under that radical. Make sure that it stays to the outside, because it's easy sometimes to do that. So be careful with the way you write these. We've got a shrink and a upshift. There's no left or right. So that means we're not going to have anything under the square root symbol except the x. So you have the 0.5, that's your shrink, square root of x, because there's no left or right shift, and your plus 3 is outside the the square root symbol because it's a vertical shift. So on this next one, 18, reflect across x, stretch by 3, 1 unit down. Again, no left or right. So you have y equals, you have negative square root of x, and then you need a 3 in front because it's a stretch by a factor of 3. The reflection, the stretch, no left or right, and then 1 unit down will be a minus 1, not under the radical. Okay, so we have a reflection, we have a stretch, 5 left, and 3 up. Y equals negative 2 square root of x plus 5, 5 units left, and plus 3. Okay. All right, now moving down to the graph. Let's look. We look to see how much from the origin this is shifted over and up. So we need to go over and up. So we've gone left. To get there, we have left 2 and up 2. And we have up 2. There is no stretch. And to come to that conclusion, I look here and I can see that my move is over 1 and down 1. And over 4, 1, 2, 3, 4, and down 2. That's the standard move for a square root, so there's not any stretching on it. Okay, so my equation is going to be y equals, there is a reflection that I didn't write because it opens down or it goes down, so there is a reflection. So I have a negative in front. Left 2 is going to be x plus 2, and up 2 will be a plus 2 outside the square root symbol. Okay. Now, linear and absolute value functions. So these first two functions are pretty straightforward. This is a constant function. And you already have that written on your parent function chart. So I'm going to go through these pretty fast. Except I can't write. So, constant. Okay. So it's at 3, 1, 2, 3. So it's a straight line, horizontal line at y equals 3. So no matter what x is, y is always 3. The domain of any line is negative infinity to positive infinity. And for most lines, that's also the range. But when it's flat across like that, the range is just that one number, 3, because all the y's are the same. Okay. Then we're going to go down to the linear function, y equals x. And this one is a straight line. Then it's going to go from corner to corner through the origin. Again, this is already on your parent function chart, so I'm just going to draw it in real quickly. The domain is negative infinity to positive infinity, and the range is negative infinity to positive infinity. And we're going to use, when we see graphs, you can lose translations for them, but we're going to do y equals mx plus b. We're not going to worry about left, right, up, down. Okay? Now, this is the new one. We did this, we did absolute value equations earlier this year, but I don't think we graphed them. So I'm going to pick x's, and y is equal to absolute value of x. So if I pick negative 5, absolute value of negative 5 is 5. I could pick negative 2, that would be 2, 0, 0. I could pick 3, 3, and 8, 8. Okay, just random x's. Y is the positive value of that. So if I have 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. A dot there. Negative 2, 2, 0, 0, 3, 3, and 8, 8. And you can see that the basic shape of this is a V, and it's going to go through every it's going to go from corner to corner, and it's going to go through every intersection of every grid line, grid mark. So it's basically two lines that form a V slope of positive 1 and negative 1. The domain is going to be negative infinity to positive infinity. Okay, and the range is going to be from 0 to infinity. So I want you to take that and put it on your parent function chart, because that's something that's not on there yet. Okay. So now let's move on and get these rest of these notes done real quickly. We already know, hopefully you know enough. Okay, this is a line, but you can still shift. We can still say the transformation. This is going to shift the line up 5 units. Okay. This is a line also. Again, the only power of x is x to the first, but since it's grouped in with the x, it's going to make it go left 5 units. And this is a reflection and stretch by 2. So much like we've just done, those things hold true. Now we've got the absolute value graph, and this is a stretch by a factor of 2. Okay. This next one, we're going to, inside the grouping symbol, which is the absolute value marks, you have minus 5, so that makes it go right 5 and up 2 units. Okay, so the last one that you see is a reflection. Then you've got a stretch by a factor of 2. You've got a left shift 5. And then you've got, it's going to shift down 2 units. Okay. So these follow the same exact rules as all these other things we've done. And that's one thing with this parent function unit. I want you to see that they're all the same. Once you know the basic shape of the function, what causes them to go left, right, up, and down is the same for every single one of them. All right, so then we go to graphing. Now with a line, again, I want you to graph it like we've always graphed lines. So this 3 is your y-intercept, and this negative 2 is your slope. So you're going to count either negative 2 over 1 or 2 over negative 1. So you're going to put your dot at 3, and you're going to go, if you go up 2, you're going to go left 1. If you go down 2, you're going to go right 1. And you can keep going down 2 and right 1 until you run out of graph. And then you can draw in your line. Okay. So, the domain for any line, other than a flat one, is negative infinity to positive infinity. And the range is also negative infinity to positive infinity. Okay. Moving on. X minus 5 plus 2. Absolute value of x minus 5 plus 2. So this means we're going to go right 5, and we're going to go up 2, and there's no stretch or no reflection. So it's going to be a V pointing up. So we start at the origin because that's where our usual vertex is, but we're going to count right 5. 1, 2, 3, 4, 5, and up 2. And there's our new vertex. And with these, if there's no stretch, you can put a dot at every intersection Every place those grids cross each other. And you can sketch in then your absolute value function that's shaped like a V. So this domain, again, for absolute value, it's the same as quadratics. It's negative infinity to positive infinity. For range, your lowest value here, the y value, is a 2, and it goes up to infinity. And if you're not sure, you can say that this point, the coordinates of that point are 5, 2, and your y value is 2, and there's nothing below 2 in this graph. Okay, so moving on, we've got another absolute value graph, and this one is going to go right 2 and down 4, and there is no stretch and there's no reflection. So we're starting here. We're going to go right 2 and down 1, 2, 3, 4. And, oh, I'm sorry, that's not a square root. That's a line. So the reason it's a line is there's no absolute value marks. So instead of doing this, I just want you to combine the negative 2. X minus 2 plus 4, that's going to be x plus 2. And then graph that line. You have a positive 2, and you have a slope of 1, so over 1, up 1, over 1, up 1. And then you can just draw your line through there. Okay. Now with this one, we have, this is absolute value. I'm reading that correctly. There's a reflection. There's an up 1. There's no left or right. And there's a stretch by 2. So, we start at our origin. This is our normal starting place. We go up 1. There's no left or right, but we do have to start up 1. Now it's going to open down instead of up, so it's going to look like this when we're done. So instead of going over 1 and up 1, I'm going to go, normally I would go over 1 and down, but since it's a stretch, over 1 and down by 2. So, and then from there, over 1 and down by 2. Okay, over 1 and down by 2. So these you can stair step these down like you would a line. And so you notice this does, just like the quadratic, that stretch makes these get skinnier and taller. So the domain is negative infinity to positive infinity, always on an absolute value. The range is negative infinity, and it goes up to 1 with a square bracket. Now we're going to write the equation of some lines. Up 3 and left 4. So it's going to be y equals absolute value. Left is x plus 4, and up 3 is plus 3. I'm going to make this, instead of x, I'm going to make it y equals x squared. So reflect across the x-axis. This makes you go back and remember something we did the other day. So y equals a reflection. Right shift, so it's x minus 6 squared minus 2. Okay. Now we're starting, this is important because it tells you what symbol you need in your grouping symbol you need. Like that one, I needed an x squared. This is absolute value again. So y equals, reflect across x, stretch by 3, left 4 means you have x plus 4 in the absolute value marks, and down 1. And then the last one, the 7, Y equals, again, we're starting with the absolute value of x, so you've got 0.5. There's no reflection. There's no left or right, so it's just x in the marks, in the absolute value marks, and down 4. If there's no left or right, it's just x in there. Okay, so now let's move forward to the rest of these. So we'll do these last two. So actually I'm not going to do 18 and 19 because those are lines. I'm just going to move on to 20. This is a line, but we can read it. The y-intercept is -2. So we have y. You have y equals, and you're going to have -2. Then you have to figure out where your slope is. And so when we look at our slope, from here, we're going to go up 2 and over 1, up 2 and over 1, up 2 and over 1. So the slope is 2 over 1, or just 2. So it's going to be 2x minus 2. Okay. This is a V shape, so it's an absolute value. And it opens down. So we're opening down. We shifted left 3 and up 2. And it looks like there's no stretch. So we have y equals negative, absolute value marks, x plus 3 plus 2. Okay. Then we're going to go up. Is that the last one? 22 is the last one. All right, so this one opens up, but it shifts down 3 and over 1, 2, 3, 4. So it's down 3 and right 4. And is there a stretch? Normally, no stretch is over 1, up 1, but we're going to go over 1 and up 2, over 1 and up 2. So this one does have a stretch of 2 on it. So this is a stretch by 2. So here we go. We're going to write y equals 2, absolute value, because it's a V, x minus 4, because it moved right, and then minus 3. So work on your homework for the rest of the period, and I'll answer questions when I'm back next time.